So thank you all for spending some time with us today. We're going to talk to you about best practices for 3D scene services, not skiing services, as the misspelling in the program had. I'm very lucky to be joined up here on stage by Sean Morrish and Tamrat Belayneh. And Tam is our lead software developer for 3D services at Esri. He's been at Esri for a while, 17 years or so, and he focuses on our 3D web services. And then Sean is a 3D product engineer. Sean is like we have the make it guy, and then we have the break it guy. So, and then we have the complain about it guy right here. So it's 5:30, guys. You know. So Sean has 15 years AEC experience. He's one of the few civil engineers at Esri, so he actually understands 3D. He's been here for about 4 years, and it's been a real pleasure to work with him, and Tam too. And then I'm Chris. Yes, there you go. So I'm Chris, and I've been at Esri for only 2.5 years, but actually, not this year, but last year, the second boss that I ever had in my career was one of the display folk. His company was displaying in the hall. I've been around the Esri community for a long time. I've been in the AEC space pretty heavily, but also I worked at the Kennedy Space Center. I took a year in molecular biology visualization. I've done a pretty big diversity of things. My role here is 3D product manager at Esri. All right. So Dragon's heard this about 3 times today, but that's okay. So there's a not so subtle message in this slide that actually a lot of people, even inside Esri, have taken a while to get. And so what I show in words is that geospatial 3D is already all around us. But what the image in the background is meant to convey is that it's actually a veritable tidal wave that is actually confronting all of us in this industry. Just one example, the partner who is demoing with us at the last session, I have 0.5 terabyte of their data in i3s scene layers on my drive, on my laptop, and I can use all of that at the same time in ArcGIS Earth. And you know, the scale of data, the volume of data, point clouds, stuff that's been around for a long time, stuff that's brand new, like these big 3D meshes, 3D objects, all kinds of stuff. There's a ton of data that's coming at us, and our customers, our users want us to enable them to be able to use it and develop with it and derive value from it. One example of the type of data that we're going to talk about today is cities. Cities have gray box buildings, they have high fidelity building models, they have BIM information, they have lots of other stuff. And we end up in lots of conversations about how can I get high volume 3D city information distributed to web and mobile and lightweight experiences. Huge tins. I don't typically use the word tin, but this is what Vricon, this partner, uses. These guys produce these massive integrated meshes that are, it's called integrated because it's the texture fused with the geometry. They are, in this case, theirs are produced generally on 10,000 square kilometer packages. The largest one I have is 120 gigabytes, and it loads in Earth locally in about 15 seconds. And it can also be accessed up in ArcGIS Online. And so this is something you can touch today, and then we're adding more functionality to it in the near future. Point clouds, another example of a widely available potentially massive set of data that has 3D information along with other information. And we just released a specification and capability to allow you to serve out scene layers as 3D point clouds. And we'll be adding to those as well over time, enabling you to use them in analytical tools and do even more great stuff with them. The goal for us is not to offer 3D as a little isolated product on the edge of the platform or as a singular extension within the platform. but to actually provide you capability to access all this great 3D information throughout the huge platform that is Esri. So if you have a customer experience that accesses GIS data and they can conceive of it in 3D, in the future, we should be able to enable you to serve data to it. And if they want to customize that experience, or you want to customize that experience on top of our basic out-of-the-box experience, you should be able to do that as well. Openness, I've been around, I've been a competitor, I've been a partner, and I've been now an employee of Esri. And what I can say is that Jack has a solid strategy for open data, open source, an open platform, and openness is a key part of 3D. We have shared out published this index 3D scene layer specification that we're going to talk about a little bit more today. We have what's it called, a patented compression format that is underneath our terrain service, which we serve out 40 terabytes of terrain for you guys to use. But actually we publicized the compression format so that you can use it as well. And we publicized the tiling pattern so that you can actually write your own applications against our elevation service. We've kind of adopted KML. We've got 100,000 ArcGIS Earth downloads out there, plus thousands more deployed behind the firewall. And we are using KML natively inside ArcGIS Pro and ArcGIS Earth. And then we of course, try to comply with other OGC standards and other standards out there in the community as well. I3S, Tam and Sean are going to talk a bit more about this. I3S is the Index 3D Scene Layer specification. It is a pattern for sharing potentially very large sets of data scalably across highly distributed systems. It is also a pattern that can be packaged up and used locally as a single file of 120 gigabytes or more in size on a hard drive out in the field. I'll let these guys tell you a lot more about it, but in addition to releasing the I3S spec under Creative Commons licensing in early 2015, we also last fall submitted it to OGC as a community standard, and it made it through the first part of that process already. Web scenes and scene layers, as a product manager, I try to help people understand what are the kind of packages of stuff that they can do things with. Web scenes are, think of those as a container in the programming sense, or a package of layers, environment settings, bookmarks, and other information, groups, so group layers, things like that, organization, that should be transportable across experiences within Esri. So a web scene can be created and published with Pro. A web scene can be created directly in ArcGIS Online or Portal. That web scene can then be reused in Pro, and it can be used in the Scene Viewer and Web App Builder and Story Maps in Online. In the future, later this year, it will also be able to be consumed by the ArcGIS runtimes. And so then scene layers are the individual, they're these big scalable things that we're here to talk about today. And we have a few different layer types today, and we'll be expanding those in the future. The whole purpose of having these descriptive terms and these specific containers for information is so that you guys can actually reuse them in additional experiences and even extend upon what we've done. Really exciting for us almost right away last year was that we started to see third-party adoption of I3S. We had Isaac Zworsky from Vricon demo with us a couple times this week. We've got Pix4D is actually the OEM software underneath Drone2Map, and then we've got other partners like Safe Software is now in prototype phase with exporting I3S content, and we have more partners that will be coming online. Bentley also offers I3S export from their context capture. It's really great to see community members taking up I3S even if they're not using Esri technology to generate it. So Bentley and Vricon do not use Esri technology to generate I3S, which is fantastic, because that's why this specification was shared out. But what they found as immediate value was that Isaac will tell this story about how he recently delivered 34 terabytes of data to one of his customers in the US government, and unlike other data types that would take 3 weeks to unpack and then distribute, he literally was able to start uploading scene layers as packages to their portal, and then as soon as the upload was done and the scene layer was unpacked automatically in the portal, users were able to hit it with Earth and web scenes. That's pretty powerful. Whole new capability and access to data for those users. All right. Last slide for me is, I just want to emphasize to people that there's this thing in Silicon Valley that is like yesterday's customer is not tomorrow's customer. Actually, for Esri, what I've realized, and I've been in the Esri community for a long time, is that actually that's not true for us. Yesterday's customer is tomorrow's customer. We look at serving the same customers that we were serving yesterday. Large enterprises that are all on-prem, small enterprises that want everything hosted by folks like us or by folks like ROK, and then hybrid scenario where they want both. Well, the big change is that yesterday's customer has learned that for the same price they paid 5 years ago, they can now get this far more rich data type that has this other thing called 3D in it, and now they're contracting out and paying for 3D content collection. And then they want us to help them use it. There is no vendor that sells data that I've talked to in the last 2 years, remote sensed or even ground-based, that isn't using, collecting, or creating 3D information. So if it's out there and users can buy it, you know that when they bid out new collection projects, they're going to be asking for 3D. And that's not even factoring in the BIM world and adjacent engineering worlds where there have been people creating 3D content for 20 years, and now they're seeing the potential of being able to use it inside Esri with their GIS data. So it is the same customers, but we all need to realize that our customers, some of your expectations have changed about what kinds of data you want to work with. So, all right, enough momentous stuff for me. On to the real stuff. So we're going to go over to Sean.
4. It's 4, I believe. Yep. Yeah. All right. So as Chris gave a broad outline, I'm now going to kind of deep dive into working with 3D scene layers, publishing 3D scene layers, the different types that we now support in the i3S format, and then both the consumption in ArcGIS Online, and then the pulling back in and reconsumption in Pro as well. So as Chris said, we go across all sides of the platform and in both connected and disconnected with the i3S format and the SLPK format. The initial set of layers that were released were 3D object and point scene layers. We've added integrated mesh, and the latest addition now has been the point cloud scene layer. So point cloud, so Chris mentioned LiDAR as being one of the main sources for point cloud scene layers, but it doesn't have to be just LiDAR. It can also be NetCDF or Bathy data. So any large point cloud data sets we'll be working to consume. Right now we consume the LAS format, which and structured in the LASD data set type for publishing of the LiDAR data points. And just to give an idea of the content profile that we support and what the output will be. And then on the bottom there you see analytics. So right now it's primarily a visualization format, but analytics, as you may have seen this morning in the plenary, there is the ability to do hit tests on point clouds and hit tests on 3D objects and get back the data-rich information that is in that, or to compare it to, as in this morning's point cloud, to actually hit the ground and see how high the Brooklyn Bridge deck was. So that's one of the things that we'll be working on. So I'll go straight from here to show you what we can do within the actual ArcGIS Pro. So in Pro, and working through all of the different data sets we have, our 3D objects. So this is St. Louis, Indianapolis, 3D objects collected by PLW and extracting out photogrammetrically correct building forms. So they're 3D meshes, or they're the multi-patches. Then we have points, 3D symbols. We also support the actual symbol layers as well. And then moving forward into LiDAR and also integrated meshes, we have various data sets which allow for that as well. And one of the things that we're also working on is when LiDAR data and integrated mesh data, so anybody who's ever used a drone to collect imagery and then has used one of the tools to create an integrated mesh, you'll find that because it's using, unless you're using ground control points, you're using the GPS to actually position your data. So that ends up being in a vertical coordinate system which is ellipsoidal, and we're working with orthometric, so we want to be able to lay the data down on top of that. So we will be supporting vertical coordinate system transformations to be able to both present that in Pro and also in online as well. So Chris mentioned Vricon's huge data sets, integrated mesh, and also the meshes from Bentley Context Capture. And this is the example of the scenes for Girona in Spain. And you can see that it meshes, or it layers quite well with the surrounding terrain, even though it is collected differently. And part of that is the fencing that is applied around the actual data itself, so that there's a good merge there. And then moving towards integrating all of those data sets. So here we have a Bentley Context Capture data set for Orlando, but we also have a set of data which was collected by Regal, and they collected airborne, mobile, and terrestrial. So with the airborne, you can see it gives a general collection of what's happening in the area itself, the building structures. The mobile gives a much more detailed example, or much more detailed and deep and rich set of data for the actual streets, where you can actually see the manhole covers and also the street center lines. And then the terrestrial will give you the the fronts of the buildings as well. So you can, as you can see, these have all been located very close together and have actually been registered together, so you can have a single, very tightly created set of data for an area that you want to work with. So this is all wonderful to be able to do this on the desktop, but if you want to actually get this out and share it, as Chris says, you want to be able to turn it into an SLPK. So how do we do that here? So we've been working, Tamrat has been doing most of the work
Others too.
There are others, but I mean, if I have a problem, I always talk to Tamrat. He's in the office beside me anyway, so we have this geoprocessing tool. So the initial output for this geoprocessing tool was to generate 3D buildings, SLPKs. Now it actually, wrong one. Now it actually supports the generation of 3D object SLPKs, point symbol SLPKs, point cloud SLPKs. It does not do, we do not generate multi-patches from Pro. The generation of multi-patches is done by Drone to Map or the Pix4D or Vricon, as Chris said.
Integrated mesh.
Integrated mesh, yeah. So bring up the create scene. All right. So the create scene layer package we have an input, and then we have an output for that scene layer package, and then we have the ability to reference to create a spatial reference for that. There is a transformer built into the GP tool, which will allow you it'll default to Web Mercator, and so it'll map seamlessly to ArcGIS Online or to Globe. But you can also generate the local coordinate system as well. So if I go to, these are quite large data sets, so I'll go to something a little bit smaller. So this is Portland. This is a classified LiDAR data set. We have ground and buildings and some trees. The input data set we will use is Portland. And then we can specify, you see it automatically specifies global, but you can also specify its local coordinate system. So this is NAD83 UTM, international feet. And you can place an output. And then run your actual scene. So, and you can see what's happening as it's running. In this case, we only have a single LiDAR data set, but if you have a large LAS data set, it will iterate through each of the tiles and package those up and output those. So we've generated the layer package. We go to our output. And you can see we have quite a small data set here. So the actual the LiDAR point data set is in the region of about 80 meg. It compresses it down to a 16. So that is one of the great things about this is for some of the data that I've worked with, I have over a terabyte of point cloud data, which ended up being a 400 gig SLPK. So it compresses it down quite good. And so now if I want to publish this, I can either go to my portal or to ArcGIS Online. So ArcGIS Online in the latest release supports the publication of point symbol SLPKs, 3D objects SLPKs, and now point cloud SLPKs. So just add it. Give it a tag, and it will upload to ArcGIS Online or to Portal, and then once it's uploaded, it will automatically publish it. There are some things to remember when publishing SLPKs. The automatic publishing tool for ArcGIS Online or for Portal limits you to a data set of 1 gig or less. If you have larger data sets than a gig, it is good to, there are tools added in both Pro and Desktop, which allow you to input the package, give a description of the package, and then add the tags and credits, and then upload that to your portal or to ArcGIS Online. And then once it's been uploaded, you then need to actually go in and manually publish it at the moment. But and then it gives you the opportunity of publishing really, really large data sets. So we go back to, yep, it's still working on it. So this shouldn't take too long. It's actually, so it's been uploaded and it's been unpacked online, and now we have it finished, and we can open it. And this, because I published it in a local coordinate system, as you can see here, it has dropped the base map. So what we have is a local scene in the NAD83 coordinate system, And if you want to do, the good thing about using a local coordinate system is that it gives you the opportunity to do subsurface. So if you have subsurface data, you can look at it in the local coordinate system. Or if I wanted to, I'll go back. Just open a global example. And this brings, so you can see the same data, but in 2 different coordinate systems. And if I have other sets of data added on here, I can bring those in. So I have a highly detailed local elevation model. So, as Chris said, in some places you have the elevation model isn't as detailed as you would like it, but you can add the local elevation service as well. And we can add 3D objects here for the scene. And you can add other sets of data as well. So that's just a simple, quick example of publishing from ArcGIS Pro, and it works for both for all of the different layers. So 3D objects, point symbols, point clouds, and from drone to map, the 3D the integrated mesh.
Just a quick comment. The point cloud publishing is really fast. I published 2 or 3 gigabytes for Washington, D.C. from one of our partners, and it published in just a minute or so. So, I mean, it's super fast.
Yep. So speaking of both the speed and also the capabilities, as a test, I've done some publishing. This is for Sonoma County. They had the whole of the county scanned. It's 60 billion points. It has elevation, classification, and RGB. And then you have the ability to traverse it and actually open up the different areas. And this is the Sonoma Raceway. And you can see that, having a nice a good digital elevation model underneath it would make this pop so much more. And simple, quick navigation and good rendering. And we can change the renders as well. So right now we have RGB. We can change that to classification. So we have our buildings, we have our trees, and we have ground. And this is all streaming, from ArcGIS Online to us here over the network. And if I needed to, I could just take this package as well, and I could look at it locally in ArcGIS Pro. So going from there, if you wish to reconsume that now, so if people have shared the data and they want to, it's up online, but say you want to do some asset management, we can add that data back in. We don't need to have the data locally or on our server or connected to a network. We can actually add that data, and in this case I'm adding a project which has been created on ArcGIS Online. And it will allow us to pull that whole set of data down and actually have that on your desktop, being able to consume it and look at the different features that are in that data set as well. So this is data from the company Cyclomedia. It's Schedem in the Netherlands, just adjacent to Rotterdam. And this is photogrammetrically collected data for streets. So they're doing street inventory. And you can make out the crash barriers and the actual line work as well. And the interesting part about this data is that it actually goes beneath the river and pops out at the other side. So you can navigate below the surface and actually follow the tunnel underneath the river and actually see, as you can see, it's dark in the tunnel. So you're not actually going to be able to make out a lot, but you can make out some things with that as well. So that kind of, in conclusion, that kind of covers the full cycle of consumption of data, setting up of data, getting it in the correct coordinates, getting it set up in your scene, and then publishing that data to an SLPK, and then taking that and putting it either to ArcGIS Online or to locally distributed to other users as well. So I'll hand over to Tam now, who will give us a deep dive into what's running behind all of that.
Cool. Thanks, Sean. And I think I'm number 3. Is that?
Yeah, it's just I need to share again. Display again.
White. It's not good. All right, good. Cool, thanks. Just a quick show of hands. How many of you attended the I3S session that was given at 4 o'clock? Only 1, 2. Okay, Esri don't count. 2 people. Okay, I was just trying to gauge, see how much in depth I should go in here in this session. We have about 18 minutes or so. So I'll try to be a little bit quick on the slides and then maybe actually see some demonstration of the format and the content. So let's begin. So Chris has mentioned and Sean has also demonstrated that I3S is supported in a variety of third-party software. Raycom, Bentley, Pix4D, Safe Software, and whatnot are outputting content in I3S format, and some of them are actually also consuming it. But within the ArcGIS platform, what are the pieces that you can use to actually generate or publish I3S content and as well as consume it? Well, we have plenty of offerings. First comes up is ArcGIS Enterprise. This consists of the ArcGIS portal, or portal for ArcGIS as it's known, ArcGIS server, and then all backed up with the data store for storing the content, the I3S content into enterprise data stores. ArcGIS Online is also another client of I3S. You can directly publish content to ArcGIS Online using a scene layer package, or brand new right now actually in beta is that you can directly publish scene service layer from an already existing feature service. So this is a really good way of creating scene layers out of existing content. A lot of our user base already have feature layers, point feature layers, for example, that have been hosted in ArcGIS Online. So why not be able to create a scene layer out of that? So ArcGIS Online allows you to do that. Drone to Map, as it has been mentioned, is another software that we have in our suite of products. Drone to Map allows you to generate integrated mesh type of I3S layer, and then you can again use that directly either in ArcGIS portal or online or the desktop applications that Sean has been showing. New in this year is that Esri City Engine 2016.1 now started outputting scene layer package. This is again a great way of getting content directly from the beautiful maps and layers that you can create in City Engine. So now you can actually just generate a scene layer package from Esri City Engine and be able to publish it to your portal or your ArcGIS Enterprise or online and be able to consume it. And of course, lastly, but not least, ArcGIS Pro, as it's been shown, is the primary or one of the major desktop application that allows you to generate scene layer content and also consume it. ArcGIS Pro kind of plays this dual role that you can actually use, as Sean was showing, the scene layer package tool, create scene layer tool to create a scene layer package directly, or you can actually just push content to your ArcGIS Enterprise or online from Pro, and the actual creation of the content happens on the server back end. As far as consuming it, obviously ArcGIS Online, ArcGIS Portal, web scene viewers can consume i3s scene layers. But brand new ArcGIS API for JavaScript 4.0 is the ability to use scene layers in your own JavaScript API, in your own custom application. And this is actually a great addition that you can actually build your own 3D web maps. There's a sandbox that you can play with and experiment with, and this has been a great addition to the suite of products that we have that support i3s. So that kind of completes the web offering. As far as desktop is concerned, ArcGIS Pro, ArcGIS Earth is the videos and slides that Chris has been showing can directly consume a scene layer package and also a service. So both desktop products that we have can directly work with i3s content in its scene layer package format or as a service. And now brand new at ArcGIS Runtime version 100 is the ability to consume scene layers directly in ArcGIS Runtime application. So applications that are built with ArcGIS Runtime should be able to consume also scene layer or i3s layer directly within the runtime environment.
Earth is runtime.
Ours is also an example of a runtime app. I was actually mentioning more of the SDK application that you can build to run a mobile.
10 to 6.
10 to 6 is in ours. So plenty of applications left and right that allows you to create content and also consume it right back. So let's talk a little bit about what is it. What is i3s? i3s supports this storage and transmission of very large discrete data sets, which could be millions of discrete 3D objects with attributes, or integrated surface meshes that may cover thousands and thousands of square miles, as we've seen in the case of recon data sets. It was designed from the ground up to be both cloud, web, and mobile friendly, in that it is based on modern web standards, JSON and REST, and as a consumer of this data format, you should be able to access it from a variety of formats. Chris mentioned this earlier in his slide as well. i3s is now in the process of being adopted as an OGC community standard. This is really great for the community, for the GIS community as well, that more adoption of i3s is actually going to help increase the visibility of the format, and also going forward the functionality and breadth of coverage available within this specification. Scene layer package, we've seen it left and right. Scene layer package is a single file that allows you to capture the complete node tree and its resources into an archive. This archive supports actually direct access to the individual resources that are contained within it. So we view i3s, Index 3D Scene Layers, as a common tool to package and disseminate a variety of GIS content that you can then turn back and consume in a variety of client application. i3s is published under Creative Commons license, very liberal, and is also available at is available at GitHub I3S spec. I won't delve much in this slide, but there are a few tenets or kind of design principles that we set out to achieve when we started working with I3S. Web and mobile friendly. Obviously, it needed to be web and mobile friendly if you plan to use it in a web app and mobile application. But it also needed to be extensible. So the current I3S specification describes fully at least four data types, 3D objects, integrated mesh, points, and point clouds. But the system or the specification is extensible in that new and more additional data types could be easily added and amended. It tends to be declarative in that as a user, you don't need to have implicit knowledge about the content of this data, or in other words, you should be able to figure out the content of this layer just by traversing the different resources that are included with either a scene layer package or the service itself. Scalability is central to the I3S data structure. You should be able to publish content that is very high, large scale, very small scale, and vast geographic, covering vast geographic area, and be able to use that in a variety of products that we have. Protection, when you publish your content to ArcGIS Online or portal, you can enable named user access to it, or you can also enable security on the particular layer or on a web scene that you would want, so that you can be guaranteed that the content that you have is secure. And as I said earlier, that the I3S specification is released under the Creative Commons license and is publicly available. Okay. Let's talk a little bit about the scene layer types and profiles available within I3S. I3S has a notion of scene layer types and profiles. Scene layer types have a strong affinity with the geometry type of the data that you're trying to visualize. 3D objects, points, integrated meshes, and point clouds are the four layer types that are currently supported within I3S. And a couple of them, for example, 3D objects and integrated meshes, they belong to one profile because they have same bounding volume structure, they use the same kind of traits for reduction of the mesh. So layer types that have a similar or affinity are grouped into a profile, so that a client application that implements accessing of this profiles could turn around and consume one type and the other very easily. So a consumer of a 3D object layer type would easily be able to consume an integrated mesh without really much work. So going through the different layer types that we have within I3S, first one, as I mentioned, is 3D objects layer. 3D objects layers is your typical building exteriors that are typically sourced from GIS data, as well as 3D models that come in various formats, your Collada, OBJ, SketchUp. These are typical formats that usually GIS users have for representing 3D objects. So the first supported type of layer type within I3S is 3D objects. The second type, or its a close cousin, is integrated mesh. Integrated meshes these are mesh surfaces that represent the skin of the earth type of data, including vegetation, buildings, roads, cars, trees, all kind of combined into one layer type. These are typically derived from satellite, as in the case of Bracon, or aerial or drone imagery, as in the case of drone to map or Pix4D. And it can be derived from dense matching photogrammetry techniques, or can be calculated. So some of the demos that Sean has shown are integrated meshes layer type. Points. Points are your typical canonical point feature data that represent point of interest, schools, trees, and cars. are usually sourced from point feature data. But an interesting thing about points is that they could be combined or instanced with 3D models to give this rich set of visual representation of a scene. So points coupled with 3D models is a rich and easy way of symbolizing your scene in I3S. And then lastly, point clouds. Point clouds, again, sourced from LiDAR data sets. Typically, they are sensor collected or photogrammetrically derived, and point clouds could be used for asset verification or augmenting an existing scene that you might have. So those are the 4 types of layers that are fully specified and supported within the I3S specification. Now, changing gears, let's talk a little bit about the I3S data organization and structure. Key to the I3S, or central to I3S, is the ability for a client application to traverse the I3S tree or node structure without ever requesting data that is required for visualizing. So this whole organization of information using a hierarchical node-based spatial index structure in which each node's payload is associated with geometry or texture or attributes is central. So a point I like to drive here is that a client application never needs to get the geometry or texture or attribute associated with any particular node until it's time to render it, but still could traverse that tree up and down very easily, very cheaply, to decide which node it needs to request to visualize at a certain zoom level. Looking at one of these nodes, the physical organization of one node, there are a few resources within that node that are really critical. The node index document is the entry point, and this is the one that I mentioned earlier that a client application always gets at first to know the content of that node. Is it good enough to render at this level of detail? If not, should I get the child of this node and descend down and request it or not? So that decision is made without really requesting the actual geometry or texture data. So node index document, a lightweight JSON resource that describes the topology of the node within the tree and includes reference to other sub-resources. Another one is the shared resource document. This is just a descriptor document that is used for describing the material and image resources of a node. Then, I had those marks here. Then there's a feature data document. Feature data document is also another JSON resource, text resource that contains the identifiers of the set of features within that node. So in the case of integrated mesh, for example, or 3D objects, the mesh segmentation information would be stored in that so that you know redundantly actually, so that you know which object ID or which feature ID is associated with what feature. And then lastly, the binary resources, the actual payloads of a node, are the geometry resource and the attribute and texture. These are the actual resources that actually contain the positional values or normals or texture coordinates for a given layer type and are used for rendering purposes. But as I said earlier, they only get requested when it's really time to render that particular node of interest. Going on forward, there is a concept of LOD. LOD is central. I3S really promotes this concept of discrete levels of detail within the I3S data structure. Each discrete level of detail represents discrete features and nodes where a more detailed representation of a node and its features fully replaces a coarser representation of the node, and the replacement applies across the features or elements covered by that node. So each node at any given level represents all the features that are bound to that node, and its child or parent also will have an alternate representation or a discrete representation that fully represents that particular node at that level of detail. Another concept within I3S is the selection metrics. A selection metrics, for example, the LOD selection metric is one typical LOD selection metrics is this maximum screen size that the node may occupy before it is replaced with the data from detailed nodes. So concept of maximum screen size and LODs makes the I3S data structure very robust and scalable. Next slide, I3S consumption. I3S can be consumed either as a service via the REST API or locally as a file system. When I3S's nodes and associated payloads reside on a server and are returned to the client, they are said to be as a RESTful service. And we have a set of REST APIs that are documented at the I3S specification that declare the kind of REST APIs that a client application need to ask from a given I3S layer. The same aspect, the same concept also applies to a scene layer package. A scene layer package also mirrors the same REST APIs that are available from a scene service layer, but within the package there are named resources. So there's a named resource for attributes and geometry and feature data that a client application could directly access from the scene layer package. The system allows flexibility. I3S system has flexibility, and a couple of examples of this flexibility include the ability to have different minimum bounding volume defined within a particular layer. For example, 3D objects and current integrated mesh typically use minimum bounding spheres to do the minimum bounding volume estimation, whereas point cloud layer uses oriented bounding box. There is a desire and ongoing work to harmonize this across the different layer types, but it also shows that the specification is flexible enough to allow different types of minimum bounding volume. Same goes for how the nodes are stored. The node structure could be stored in an expanded format where a client application will ask each node before it can visualize it, or it could be fixed or in a paged node where you would ask actually a number of nodes together as one and then locally discover those nodes or locally discover the nodes that you just fetched from the service or the scene layer package. So all this flexibility is built in within the specification. Yet another flexibility within the system is this notion of having embedded or binary geometry or attribute content. Point scene layers, for example, embed the geometry or positional data within the feature data itself, whereas 3D objects and integrated mesh layers and also point cloud have reference from a node by reference the geometry and attribute data in a binary format. So all this is again supported and promoted within the I3S system so that you can use the right tools for the right purpose. There is a different set of LOD selection criteria of a node, how you would select a node to be able to display it on a screen or not. There are a few selection metric types, maximum screen threshold typically used within 3D object and integrated mesh. Effective density is used for point cloud, and a few others are used screen space relative and distance range from default camera is used by point scene layers. Quickly going over the scene layer package. So what you see here is a visual representation of a scene layer package. Scene layer package typically consists of or it needs to consist of this 3D scene layer JSON. 3D scene layer JSON is the entry point to that package. It defines and describes the content of the layer, either from default geometry data type or the special reference. All that information is stored in the 3D scene layer JSON. Interesting thing about the scene layer package is that this package is a zip archive, is a zip64 archive that is not compressed, or that it was no compression or only with a store compression or only used as a storage. So this is central to the fact that you can drag 160 gigabytes of scene layer package and drop it in Earth or ArcGIS Pro and be able to immediately consume it, because since there is no top level compression applied on the package itself, a client application can actually access the individual resource directly from a scene layer package. And there are other things that we've been working on, typically, for example, point cloud layer or a scene layer package for point clouds actually additionally includes a hash table, an index that you can actually use to even more efficiently traverse and discover a scene layer package directly. So here are some handy notes that I kept here, REST resources to keep handy. I use them all the time to discover from your portal the REST services that are hosted, even to submit jobs directly, and also find out where your home portal is. We're really running late, so maybe I can wrap it up at this point and then open it up for questions.
All right, thanks very much, Tam and Sean. So I just want to make one quick comment. If there are any folks in here who are interested in producing i3S content, the Vricon folks basically got our GitHub link last year and produced their first scene layer package in 6 days. And it's even easy enough for a PM like me to take a package, crack it open in 7-zip, and inspect it for QA. I've had to do that with some of the partners that are generating i3S. So it's something that's definitely accessible to everybody in the room. So do we have any questions from the folks that hung up? Yes, sir. Are there any i3S foundation tools? You mean like validation tools?
Let me put this slide right here, actually. In the last slide that I have was we are already currently working on an i3S validation tool that allows you to validate. This is slated to ship with ArcGIS Pro 2.0. So you can point to your scene layer package, validate it, and it will tell you detailed information about that particular scene layer package. Yep. And there are others that we're also working on, reprojection and optimization.
And in the interim, you can upload the packages to online and see if they work. You can also open them in Earth, and that's what the partners who've started generating their own, and also Pro. So Earth can't read the 3D point or point cloud scene layers, so Pro is actually effective for all of the above and online as well. Anybody else? It's been useful to you guys. You hung out the whole hour, so kudos to you. So I have like Earth stickers if you want a prize. All right. Well, thank you guys for attending. We're really happy to see everybody here at the Dev Summit and interested in 3D. And please feel free to follow up with us if you have any questions. Okay. Thank you.
All right. Thank you.